Okay, so today we're going to talk about section 2.1, which is about parallel lines and special angles. All right, so we see here we actually have some perpendicular lines, perpendicular planes, and parallel lines. So as you can see in this first one right here on the left, you have this line right here being perpendicular to this one. You also have this one here that has a plane that is perpendicular to this line L. Okay, we designate perpendicular by that upside down T. We also see on the far right, we see a plane perpendicular to another plane. If we look at the bottom diagram, you see two lines that are parallel. You can see a line and a plane that are parallel, and also two planes that are parallel. And when we talk about parallel, we talk about those two lines. Okay, so when we talk about two lines being crossed by another line, that other line is called the transversal. Now, the two lines that are being crossed by the transversal, so we're going to call this line here T for transversal. We have these lines. Now, they can be in all different shapes and sizes, okay? Now, we can have them very obviously not parallel, and they can be parallel as well. Okay, so when we talk about the specialties between these relationships between the angles, okay, we'll call this top line L and we'll call this bottom line M. Okay, we have corresponding angles, alternate interior angles, alternate exterior angles, same side interior angles, and same side exterior angles. Okay, so if we look at the idea of a corresponding angle means that it's going to be in the exact same place where that transversal crosses. It doesn't matter if the lines are parallel or not. So for example, if I have this angle right here, and I am in at this intersection right here, in this part of it, that means at this intersection, I need to be also in this part of it. So that means that this right here are corresponding angles, okay? If I look at, let's see here. Okay, this was line L and line M. Okay, if I look at some alternate interior angles, alternate means just what you think, right? Alternate is on opposite sides. Now, if I look at the differences between interior and exterior, interior is between the two lines, and exterior is outside of the two lines. So that means that anything in here is considered to be interior. See how it is inside those two lines? And anything on the top and the bottom are called exterior, right? Because they're on the outside. Now, if I think about alternate interior, that means that they have to be on opposite sides of that transversal. So if I were to look at this, right, I would see this is an interior angle, and the alternate one would be on this side. See how they're on the opposite sides? You can almost think of it as a Z. And they have to be on the insides there of that Z. If I'm looking at alternate exterior, we can keep going with that Z, but this time they're on the outside. So they're going to be something like this one here and this one here. Or it could be this one and this one. Either way, okay? Alternate exterior say that they are on the outside, on the opposite sides of that transversal. Okay, now when we talk about same side interior and exterior, it's exactly like what you think. Same side means on the same side of that transversal. So same side interior would be this guy and this one. Same side exterior would be this one out here and this one out here, right? Because they're on the same side. If you would like to copy those definitions down, the next slide will have all those for you. Here are some of those definitions for you written out. So a transversal is a line that intersects two or more, could intersect three or four, other lines at distinct points. all of those lines have to be in the same plane. When I look at corresponding angles, two angles that lie in the same relative position, so that's like what we talked about before in terms of this one up here at the top right, meaning that this one up here is also on the top right, so those are corresponding. Alternate interior or interior angles that have different vertices and lie on the opposite sides of the transversal, and so on. So take a moment, pause the video, and write these down if you still need to. Okay, now that we have those definitions taken care of, why don't you take a moment and give me as many pairs of the following types of angles that you can. For corresponding alternate interior, same side interior, a linear pair with angle 3, and an angle that's vertical to angle 8. So think of as many as you can for each one of these. So pause the video and do that, please. Did you come up with these answers? You should see for corresponding that you have angle 1 and 5. So that means we have this guy right here, angle 1, and this one right here, angle 5. They're in the same relative position. 2 and 6, 3 and 7, and then 4 and 8. For alternate interior, I see that I have 2 and 7, right? They're on the opposite sides. 4 and 5, and nothing else for the inside. For same side interior, I see I have 4 and 7, and then 2 and 5. A linear pair with 3. Now remember, a linear pair are two adjacent angles that are supplementary. So I look at 3 and I see that 3 and 4 make a straight line. I also see that 3 and 1 make up a straight line. And then a vertical angle to angle 8. We know that these two lines are the same, so angle 8 and angle 5. Okay, so let's think about this. When I have two lines that are parallel and crossed by a transversal, what happens? We use these arrows here to designate that things are parallel, okay? So that means that this line and this line are both parallel. Okay, so if I look at this in terms of some things that I know already, okay, I know that we have some relationships between corresponding angles. So if we have parallel lines, so if two lines are parallel, then the corresponding angles, obviously when we're cutting it with a transversal, are congruent. Okay, so that means that angle 2 and angle 6 have to be congruent, right? That's what we know. So angle 2 is congruent to angle 6. All right, now we want to figure out, okay, some of the other things. Now there are some other relationships here. Now let's think about this. So angle 2 and angle 3 are what kind of angle? So this guy right here that I'm highlighting in blue and angle 3 right here are what kind of angles? Well, they're vertical angles, okay? So if angle 2 is congruent to angle 3 and angle 2 is congruent to angle 6, then what do we know? Well, knowing by the transitive property, remember that, okay, from the other day in class, the transitive property says that if we have one thing that's equal to something else, that same thing equal to something else, then that means that angle 3 has to be congruent to angle 6. Okay, so that says that angle 2 and 3 are congruent, right? And angle 2 and angle 6 are congruent, so automatically we should see that angle 3 and angle 6 are congruent. Okay, so that also means that if we have parallel lines, okay, that alternate, I'm going to say ALT, interior angles, I'm going to say this, are congruent. So as you can tell, 3 and 6 are alternate interior angles. This also tells me, okay, that alternate exterior angles are congruent. And you could prove that in a very similar way, right? So that means that you could look at 1 and 4 and 4 and 8, right? So 1 and 4 are vertical and 4 and 8 are corresponding. So that's very similar there. Okay, so now we want to see about anything that's special about same side interior, okay? So if I look at this, alrighty. If I look at the same side interior, so that's going to be angle 4 and angle 6. So if I look at same side interior, right, we know that angle 4 and angle 6 are not congruent. There's just no way, right? One looks smaller than the other, okay? But I do know something about this right here, right? An angle 4 and angle 3 are a linear pair. So that tells me that they are supplementary, okay? So they have to equal 180. Now, one thing I do notice is angle 3 and angle 6 are congruent, right? And that's because they're alternate interior angles. All right, so now if I think about it, okay, so I know that angle 3 plus angle 4 equals 180, and I know that angle 3 is congruent to angle 6, so really angle 6 plus angle 4 equals 180 if I use substitution. So that means this gives us a really important thing, right? That means that same side interior angles are supplementary. All right, so this is important. Okay, you want to remember that, and you want to remember these two. So these three things are very, very important when it comes to parallel lines being crossed by a transversal. So these are the important things that you need to remember, okay? Corresponding angles are congruent. Alternate interior angles are congruent. Alternate exterior angles are congruent. Same side interior angles are supplementary. This also means, one thing I left off here, is that same side exterior angles are supplementary as well. All right, so go ahead and make sure that all of that is in your notes, and I will see you tomorrow.